we are going to see cryptographic hashing. So what is hashing? Hashing is the process in which we'll be converting the plain text message into a fixed digester. It can be of any fixed value. See, we have a message of, we can have in size of any, we can have the message of any size. So using hashing, we are going to convert it into the message, or the whichever is converted, that is called as digest. We will get a fixed size value which is called as the digest. So the input of the hashing is message and the output of the hashing is the message digest, which is of fixed length value. Okay. To produce a fingerprint or digest of a block of data is the purpose of hashing. So the block of data can be message, document, anything of any size. That also I will say. For a given hash function, the size of the digest is fixed through the input can be, though the input can be of any size. As I said, the input can be of any size, but it will give the fixed size message digest value. That will be the output of hashing. So the hashing actually involves so much mathematical operations, which involve so many rounds. So which is very complicated process, and it is very difficult for the unauthorized person to do the hashing operations. That is why it is so famous. And it is, since it is very complicated, it involves more time also. See, we will see the properties of cryptographic hash functions now. The first one is one-way property. So what this one-way property says? See, if I am finding the hash value of x, the message digest value is nothing but y. That is, h of x is equal to y. Always we can calculate, we can apply hashing on x and we can get y. But it is not possible, or it is computationally infeasible to calculate h of x if we have y. So one-way property, it works if, like, we can get with the message, you can apply hash and we can calculate y, but with the y it is not possible to get the value of x. That is what is said in one-way property. I'll read out the property now. Given an x, it is easy to compute h of x, but given a y, it is computationally infeasible to find an x. Reverse will not work. Always you can go in only one direction. That is one-way property. The second is weak collision resistance. Given an x, you are given with the message m. It is computationally infeasible to find z. It is always, it is not possible to find another message called z such that h of x is equal to h of z, such that both the, after applying hashing on x and after hashing on applying hashing on z, you will never get both the, you will never get the value as same. That is, message digest of x and message digest of z will never be same. Such that h of x is equal to h of x z, x is not equal to, there are two different messages. If you have two different messages, see, so that what it is said is, given an x, it is computationally infeasible to find z such that h of x is equal to h of z. See, you have one message, in your hand you have a message called x, and you have applied h of x, you have applied hashing and you have calculated h of x. So with this, unauthorized person cannot create a message called z. Always that would be, obviously that will not be equal to x. That is why he is going for the changes. If he does the changes, that will not be equal to the message what you have created. So he cannot create the message digest which is equal to h of x. He cannot create the message and after applying the hashing on the message called z, he will never get the value same as what you have got after applying the hash on x. So the hash of x and the hash of z cannot be equal for the two different messages. Is it clear? So it is, that is called weak collision property. Even if you have message with you, you cannot call x. After applying it, after applying hashing, we will get h of x. Okay, you cannot create the message z such that h of z is equal to h of x. That is said in weak collision resistance. So unauthorized person cannot modify the message, because after applying hashing on the modified message, he cannot get the same hash value as you got on the old message. So it is called weak collision resistance. Next comes strong collision resistance. It is computationally infeasible to find any two blocks x1 and x2 such that h of x1 is equal to h of x2. See, you can even not take the two different messages, and for two different messages you will not get the same hash value. That is called strong collision. For two different messages you will never get the same hash values. It is not even possible to get the same hash values for two different blocks called x1 and the x2. This is what is said in strong collision. Next comes confusion and diffusion property. If a single bit in the input string is flipped means missed, then each bit of the hash value is flipped with a probably roughly equal to 0.5. Even in the hash value, it can be flipped with the probability of 50%, that is 0.5. Next comes applications and the proper performance of crypto hash functions. It is nothing but what are the applications. First one is to create a digest of a message. The second one is to create a MAC. And the third one is to create a digital signature. The first one is to create the digest of the message. Why we have to do the message digest? As I said, for hashing, we have to convert the message into the message of any size into a message digest of the fixed size. Why we are going for the hashing? To stop the modifications during the communication, to stop the modifications by the unauthorized person during the communication. So it maintains the integrity. Nobody can change the values during the communication. If they change also, we can calculate hash and we can check very easily whether it has been modified or not. Next comes to create a MAC. So what is the use of MAC? For integrity and authentication. One is nobody can modify the message, can avoid the modification, and the second one is authentication. Authentication is nothing but whether it comes from the authorized person or not. That can be easily identified with the help of the MAC. Next comes to create a digital signature. So what are the purposes of digital signature? You can provide three things if you are going to use digital signature. That is integrity, authentication, and the non-repudiation. What is non-repudiation? See, I'm sending the message call. I will come to Chennai tomorrow. But in between, what happens after 2 days? I'm changing my plan, and I'm saying to my friend to whom I have intimated that I will come after 2 days to Chennai. I am now saying that I have never informed you. So it is called non-repudiation. If somebody refuses whatever they have already said as not said, that is called non-repudiation. To avoid these sort of problems, we can go for digital signature. So digital signature provides us with integrity, authentication, and non-repudiation. Next, hash based message authentication code. We saw, right? Message authentication code will provide two things, I said right now. That is, one is integrity and the other is authentication. What method will be providing integrity? That is, hashing will give us integrity. How can I check the authentication? That's what we are going to see now. So we have to integrate hashing with some other thing so that it can give authentication also. With what we are going to integrate, we will check. Suppose that the sender and the receiver shares a secret key. That is, we both, my friend and myself, want to communicate with each other. So we have a secret called K. If the message and the secret are concatenated and hash taken on the string, then the hash value becomes a fingerprint of the combination of the message and the secret K. So what is called fingerprint? Say I am taking a message and we have a common secret called K. I am concatenating these two, message and the K, and applying hash on it. This is called as fingerprint. Okay, and it can also be called as MAC. So what is MAC? MAC is nothing but apply hashing on two things which is concatenated. What is concatenated? Message plus key. Apply hashing on message and key is nothing but MAC. So what will happen now? He will send. I want to communicate with my friend, I said, right? So what I will do, I will send the message. Along with the message, I will append this MAC value also. Now what my friend will do, he will take the message, he will apply hash on the message and the key. How he is knowing the key? Already I said we both know this common secret, that is K. So he knows already the K, and he takes the message from the text which I have sent and he concatenates and applies hash. If the MAC value which he has calculated and which I have appended in my message is same, he will come to know that nobody has changed the message during the communication. And one more thing, since the secret key is known only to him and me, it comes from only me. He will be assured. He can confirm that this message only comes from me. So it provides two things called integrity as well as authentication. Next, as I said, the same thing is explained here. In the event of the mismatch, the receiver concludes the sender of the message is same entity it shares the secret with. Thus, the MAC provides source authentication. That's what. Since I have sent, the source authentication is ensured here. The message has not been corrupted or tampered. It has not been modified. So he will confirm that nobody has modified in between, which provides integrity. Next comes digital signature. So what it is going to provide, what are the characteristics of this is, it should be authentic, not be forgeable, should not be possible to repudiate a signature. As I said, nobody can refuse, it cannot be reused, it's not possible to alter a signed document. What is RSA signature? So perform a hash on the message and encrypt the hash value with the signer's private key. So what I am going to do, if I want to apply RSA signature or digital signature on the message, what and all things I have to do is take a message, apply hash on it, then we will get a fixed message digest, right? Take that fixed size message digest and encrypt it with the private key of the sender or the public key of the receiver. Then send the message to the communication channel. Now what happens? The receiver will decrypt with the public key. If it has been encrypted with the private key of the sender, he will decrypt with the public key of the sender and he will get H of M now. What he will do now? From H of M, it is not possible to calculate M. So what should be done? So always when I am going to apply hashing, when I want to use hashing, first I need a message. Okay, first along with the message, this digital signature also will be sent. Okay, so what happens is, he will take the message, he will apply hash on it, then he will check the hash value which the sender has sent, and whatever he has calculated on the message is same. If both are same, then he will conclude that it is sent by the authorized sender. That is, source authentication is done. Then nobody has changed in between. And even the sender cannot refuse that he has not sent, because it has been encrypted with his own private key. So he cannot say that it is without his knowledge the message has been sent. So these are the three benefits which the RSA signature can be given. That is integrity, authentication and the non-repudiation. This I am concluding my session. Thank you. Bye-bye.